All right, in this video, I'm going to go over combining functions using algebraic operations and composite functions as well. Algebraic operations would be f plus g of x, f minus g of x. Composite functions would be f of g of x and g of f of x. All right, so we might have touched on this before, but this time we're going to go over it in more detail, maybe, and we're going to have more fun with it. So let's just say that f of x is x minus 1, and g of x is x squared minus 1. Okay, evaluate the combination, then simplify. Simplifying is where people often find trouble. But first, let's evaluate. Okay, so f plus g of x. What does that mean? That doesn't look right. You might recall f of x plus g of x. That is the same thing. If this is the only thing you learn in this video, then let it be so. That these strange ways of writing this stuff out just means something that you may have already seen before. You just take f of x, which is x minus 1, right? You add g of x, which is x squared minus 1. It's kind of like substitution. And whenever we do substitution, I like to put parentheses, but in this case, you don't really need them because you're just doing addition. Now, with subtraction, multiplication, division, you do want to use parentheses because it helps you figure out where you need to distribute things, which is very important. So it's good to just be in the habit of always when you're substituting anything, always put parentheses around it because you're distributing a positive 1, right? I mean, that doesn't change anything, but it's good to keep that in mind. Now, we just combine these things, right? And we write the highest degree of x on the far left, first. So that would be x squared plus x, negative 1 minus 1, minus 2, right? Okay, are we done? No. We just evaluated the combination. Now we need to simplify. And what I mean when simplifying is factor. That simplifies things. Maybe not for you, but it simplifies things for the function that we're evaluating here. All right, so x squared plus x minus 2 factored. Well, there's no special rule here, so we're just looking for two numbers that add to get what? Positive 1, and multiply to get negative 2. Well, positive 2 and negative 1. 2 minus 1 is positive 1. 2 times negative 1 is negative 2. So, x plus 2 times x minus 1. And there's your answer to part A. It's x plus 2 times x minus 1. Let me just check my math there. X times x squared, minus x plus 2x minus 2. Yeah, that's correct. All right, next one. F minus g of x. Same as f of x minus g of x. No problem, right? X minus 1 minus x squared minus 1. Okay, well, now we're grateful that we put those parentheses in there because we're distributing an understood negative 1 to the second function in our little combination there. All right? That's why it's important to use parentheses. So we got x minus 1 minus x squared plus 1, right? So negative 1 times negative 1 is positive 1. Basically, it just changes the signs of everything in the parentheses. So now what do we got? Negative x squared plus x, negative 1 plus 1 is 0. So that's it. Okay. Now what? We got a factor. Still got a factor. Okay. Well, there's a x in common with both terms, right? And we might as well take the negative out of there. Negative x times negative x squared divided by negative x is x, positive x. Positive x divided by negative x is negative 1. So our answer is negative x times x minus 1. All right, that's part B. We're going to run out of room here pretty soon. Part C, fg of x. All right. That would be f of x times g of x. Write it a different way. Put a dot there for multiplication, right? We can't use x for multiplication because we're already using x for other things. All right, so what do we do? X minus 1 times x squared minus 1. Remember, when you're multiplying binomials together, you got to use the distributive property. So x times x squared is the FOIL method. X cubed, right? Minus x. First, outside, inside, last. Minus x squared, right? Negative 1 times negative 1, positive 1. Ooh, okay. All right, let's line them up. X cubed minus x squared minus x plus 1. All right. Now, don't panic. I'm going to use my favorite type of factoring, grouping. We just kind of group the first two terms together and the second two terms together and just factor those, right? See if we get the same thing in each of them. Okay, so what's the greatest common factor of x cubed and minus x squared? That would be x squared, right? So just left with x minus 1. Well, this doesn't look like x minus 1, so we factor out a negative just to make that x positive, and we get x minus 1. Well, what do you know? X minus 1 and x minus 1. Since those are the same, we can then factor those out like they're the greatest common factor, and we're left with whatever they're being multiplied by, right? This is the grouping method. If you don't remember it, you can look at my video of that. All right, are we done? No. This is difference of perfect squares, isn't it? So we can factor that again. Ugh. Let me just be weird and go over to the left here, because I have more room over here than I do over there, right? All right, so we have this x minus 1 already. We're not messing with that. This is what we're factoring. X squared minus 1, x plus 1 times x minus 1. And that is your answer. Some teachers might prefer you combine those x minus 1s. So that is also an acceptable answer for part C. All right, I'm going to erase this real quick, and then we'll do DE. DE and F, not D again. All right, let's do part D. F divided by g of x, which is the same as f of x over g of x, right? Okay. X minus 1 over x squared minus 1. That looked awkward. Okay. Gotta simplify that, right? Oh. X squared minus 1. We just did that, right? The difference of perfect squares. Gotta factor that. X plus 1 times x minus 1, right? Oh, look at that. That is the same as the numerator, which means it can cancel out because x minus 1 divided by x minus 1 is just 1. So we're left with 1 over x plus 1. Don't need parentheses for that. Our answer there. That's part D. All right, part E. Let's do that one. F of g of x. Now, this is where the composite functions come into play. Composite functions are functions within functions. Makes perfect sense. All right, so if f of g of x, then f of g of x is what we're going for. So the output of g of x is the input for f of x. Does that make sense? So we take f of x, x minus 1, and instead of x, we put g of x. That wasn't so difficult. All right. Do parentheses do anything? We need to distribute anything? No, we're subtracting 1 from whatever this is. So it's just x squared minus 1 minus 1, which is x squared minus 2. Can we factor that? 2 is not a perfect square. There's your answer. All right, what about g of f of x? Let's try that one. G of f of x. Oof. So we take g of x, right, and we substitute f of x in for the x in g of x. So x minus 1 squared minus 1. That's quite the difference between the two. X minus 1 squared. A binomial squared means we're distributing. Got to remember that. X minus 1 times x minus 1. X squared, right? X squared minus x minus another x plus 1. Not 2. And then minus 1, right? Because we still have that minus 1 on the end there. Okay, so we have to combine like terms. Positive 1 minus 1 is 0. Greatest common factor of x squared minus 2x would be plain old x. So there's your answer, x times x minus 2. All right, for these last two parts, we're going to make things a little more complicated. However, we have our answers from the previous parts to help make this go a little faster, all right? F of g of x minus g of f of x. Well, we remember what g of f of x was and f of g of x, right? So f of g of x would be x squared minus 2, right? Minus g of f of x, which was x times x minus 2. Whew. And remember, put things in parentheses. I'm using brackets because there's already parentheses in there. Okay. Well, got to distribute that negative, right? Which makes it just negative x. All right, now we got to distribute the negative x into the x minus 2. Basically undoing the work that we did before. And I'm doing that first because that's just a little bit easier than trying to distribute this into that mess right now. So x squared minus 2, bring that over. Oh, we don't have to distribute it later. Anyway. And it changes to a positive. Now we're adding instead of subtracting since we're distributing the negative, right? Negative x squared plus 2x, right? Does that make sense? I basically took the negative, distributed it, so that changes this to an addition problem. So now we can actually add things together. So x squared minus 2 minus x squared plus 2x. And now all we do is combine like terms, right? X squared and x squared. Wow, 1x squared minus 1x squared is 0. That cancels out. That was easy. 2x minus 2 is close to being your answer. That'd actually be 2 times x minus 1 because we got to factor out that greatest common factor, right? And that would be your answer. It's not so bad if you've already done f of g of x and g of f of x, right? All right, now f of g of x divided by g of f of x. Whoa, that's a mouthful. F of g of x, x squared minus 2 over x times x minus 2, right? Right. What do we do? Nothing. There is nothing to simplify. Isn't that easy?